Assalamualaikum and very good day to Dr. Faika. I am Siti Normalis Bikta Ahmad Fuzi. I will present my research project, which is synthesis and characterization of butylated oxalated diphenylamine as antioxidant for lubricant. So first of all, the additive are formulated with petroleum or synthetic base stock to strengthen or modify property of lubricant. Antioxidant is used to inhibit undesirable oxidation phenomena. The usage of antioxidant can prolong the lifespan of lubricant and reduce damaging to machinery and act as radical inhibitor. The alkylated diphenylamine is the most important classes of amine antioxidant. Problem statement. The lubricant is easily degraded or oxidized. Therefore, the lubricant needs as less antioxidant to reduce amount of deposit formed and reduce the high gas emission to environment. It is very challenging in discovering optimal parameter to produce liquid antioxidant as alkylated diphenylamine tend to crystallize. A liquid antioxidant is needed to replace the solid antioxidant which are difficult in handling, transportation and not easily to blend with oil. The objective for this research are to characterize the butylated oxalated diphenylamine using for transfer infrared. Second, to study the effect of alkylation time and temperature to produce liquid formation of PODPA. And lastly, for optimization parameters to form liquid formation of PODPA. Methodology. Firstly, for sample preparation, the setup of apparatus is shown in the poster. The diphenylamine is added into the round bottom flask and heat at 80 degrees Celsius under stirring condition until the solid form of DPA is melted into colorless solution. The aluminum chloride is added into the system and heat until 115 degrees Celsius to 130 degrees Celsius under stirring condition. After that, the diisobutylene is added into the system and colorless mixture is gradually changed color. The appearance of sample was observed for each hour. The sample is prepared for 4, 5, and 6 hours and repeated 2 times. Second, the sample is analyzed using FTIR. And lastly, the optimization of parameter is done by using RSM. Results and discussion. The table shown in the poster is appearance of product produced at 4, 5, and 6 hours. They are different in phase and color. So firstly, after the completion of the experiment, the sample is kept in another glass container for 1 day and all samples are in liquid. After 1 day, the sample produced at 4 hours become crystallized, while sample produced at 5 hours, there is crystal formed in the sample. The sample that produced in 6 hours is fully liquid. Based on Unit 2017, if the amount of unsubstituted diphenylamine and undesirable components such as dioctydiphenylamine and monooctylene diphenylamine is higher than BODPA, the mixture sample tends to be crystallized. This is because higher temperature is needed for alkylation process, which is at least 160 degrees Celsius to crack the octyl group to butyl group. This is important to produce a high yield percentage of PODPA. Next, the color of product also significant for additive quality. Based on appearance shown in the table, the sample produced at 4 hours is completely crystallized, and actually the color before it crystallized is dark brown. The color of sample produced at 5 hours also dark brown, while the color of sample produced at 6 hours is light brown. A darker brown sample is not unwanted for additive industry because it will contribute to dark color of additive package, which leads to significant market resistance. Based on previous study, The antioxidant should not be too yellow because it is significant with higher amount of unsubstituted diphenylamine in the sample, which is unwanted and might sensitize human skin to other irritants. Next, sample is analyzed using FTIR. FTIR is needed to determine the infrared spectrum of absorption for sample. All functional groups which are significant for formation of BODPA are present, such as NH stretching, CH bending, and NH bending. But infrared spectrum does not provide information on molecular fragment. Therefore, another technique is needed to provide more complete picture of molecular structure of composition of sample. RSM. The design of experiment for this study is constructed using response surface methodology to obtain the optimization for different parameters in liquid formation of BODPA. This technique uses factorial design where main effect of factor is defined as variation in response caused by a change in level. Figures shown in the poster represent the three-dimensional response surface plot and contour plot of response of Y towards time and temperature. The Y is represent the liquid formation of BODPA. For contour plot, the blue region indicates lower response of Y when time and temperature are decreasing, while it is vice versa for green region where response of Y is higher when temperature and time increase. For surface plot, as shown in the poster, the higher the temperature and time, the higher the response of Y. Next, the table shows linear regression equation for both RSM and Microsoft Excel. The parameters used are time and temperature. For RSM, the p-value for time and temperature are less than 0.05. Therefore, the equation is valid and variables are significant. The R-squared value are positive about 85%. In other hand, linear regression is run using Microsoft Excel. There are two equations constructed due to p-value of temperature is higher than 0.05. Therefore, temperature variable is less significant than time. As conclusion, the optimum parameter for this research that can be used is 6 hours for process time and temperature is at least 160 degrees Celsius. The alkylated diphenylamine must be low in yellowing coloring. Recommendation. For future work, the catalyst can be replaced to catalyst that is more environment friendly and easy to separate, such as clay. The sample must be analyzed using GCMS to determine the yield percentage for each component that exists in the sample. The thermal stability of sample must be determined using TGA. And lastly, total acid number test can be used to determine the reaction of antioxidant when blending with lubricant. These are the references that I use in this research, which is stated in the poster. I want to thank my supervisor, Madam Nurain, and faculty for giving me opportunity, support, and guide to complete my research project. Thank you.